Hello everybody, welcome back to another show of What's Up with Nick and Chuck. Today we're going to have a conversation with you guys regarding plastics. Now plastic, we're going to take and differentiate between the different applications that you would have regarding whether you're in the prototype stage, pre-production, and production, and then also what you should consider with using each material.
So in my hands here is an example of a 3D printed part. Here at HUI we've got a small 3D printer, but we also work with a lab to provide us with very large 3D printed parts. So sometimes during the prototyping stage, when we are just trying to get a feel for either the size or just basic functionality, we will quickly 3D print parts or components for different applications on a cart or something to get a visual for.
The nice thing with 3D printed components is that it allows you to have the look and the feel of what that would kind of look like in production with way less of the investment because there is zero tooling required with 3D printing.
And we can use a variety of material types. ABS is a common one that we use for making 3D printed parts. I have another part right here. As you can see, this is a very complex part, and actually this part here was one of the functional prototype pieces that we had developed. And next to us here is the actual production grade cart. And so as you can see, very similar in terms of features, and it gives you a really good representation of what the actual production piece would look like. This is a really good solution to go down the path of when you're trying to finalize the design before investing in tooling. We also use products like Cast Urethane, where let's just say we have a little bit more complex part that we just need to have a better feel of the geometry or how the device is going to interact with the actual component. And so in the prototyping stage, maybe a little bit further down the development stage, we'll have a cast urethane part made, and it'll be a very close replica of an actual, whether it's injection molded or a rim type process or even thermoform for that matter, but it's a really close representation of an actual production grade part.
The nice thing too is that you don't have to cut it off at that level. The nice thing with the cast urethane is that it is also a production method that is used for lower volume. So if you're going to have a custom cart, you want to incorporate plastics. You don't have a ridiculous tooling budget to jump all the way into injection molding. Cast urethane is a really good option because it's a relatively low cost tool, but you're going to have a little higher per piece price, but it allows you to get into that custom plastic market. Another plastic to be considered, or method rather, is that of thermoform. Thermoforms gives you the nice smooth lines, the contours, the clean finish, and the look that a lot of medical device companies are looking for. This component, for example, is a thermoform unit. The nice thing with thermoforming is that it is not only utilized in production, it is also utilized in prototyping. So this one, for example, a pre-production version of this could be machined out of a wood block, and that wood block is used for the prototyping stage, and you can get, depending upon the complexity and the size and the amount of heat, which would be dependent upon the material that's chosen to be thermoformed, you can get anywhere between 3 to 5, 7, 10 different prototypes off of that wood tool. And you can certainly get much more, it's just at that point you start to see some of the wood grain starting to come through on the plastics itself, and then it's starting to deteriorate that smooth finish that you're looking for. Nice thing is that thermoforming is relatively inexpensive from a tooling standpoint. It's relatively fast-paced in regards to providing your prototypes, and it's also very flexible in regards to volume as well. It can cater to lower volume as well as higher volume.
The only disadvantages of thermoform is when it comes to really complex, tight, when you have pieces coming together and you really want to have a nice finished seam, you're going to have a few more reveal lines when it comes to thermoform. So for example, as you can see here, we've got a little bit of a larger, and sometimes you have to have more of a larger feature so that when the cover comes over the top of the next piece, it's hidden real nice. The other thing that you'll see on a thermoform is that, as I talked about reveal lines, they're just a little bit wider. Versus when you come to injection molded, like behind me for example, here we've got some moving parts here, right? The tolerancing between the side piece and this door here is quite tight. And then you also obviously have a locking mechanism on here. So again, When you go down the injection molded path versus the thermoform, you're going to find that you can hold much tighter tolerances or much tighter surface features than what you can when it comes to thermoform. Another part that is commonly used in production is rim molding process. So rim molding is another option for plastic. It's a cheaper option than going down the path of, from a tooling standpoint, than injection molded. It allows you to still have a very complex cart with very tight tolerance features. So for example, this here is an example of this part right on this cart right here, which this is the rim molded product. This whole top surface is rim molded. And so again, it allows you to have the complexity of an injection molded part, but at a much reduced price in terms of tooling. But your per part price is going to be much higher than if you were going down the path of an injection molded part. You would use rim molding for your lower volume type products because you're going to have a much lower cost in tooling, but your per part price is going to be a little bit higher. Your higher volume parts, which would be like your injection molding, if you're going to create a few thousand of them, it's going to be a little bit more money up front in terms of tooling, but you're going to receive the cost benefit on the per part price because of the volume.
If you have any further questions regarding any of the plastics that we discussed and the manufacturing methods, please feel free to visit our website at www.medicalcarts.org and check us out on LinkedIn as well.
Thank you.
Thanks a lot.